Hi everyone, welcome to today's Megaport Live Tech Drop-In. I'm Mark Austin. I am a pre-sales solution architect based in Sydney. I help customers architect network security, cloud architectures on Megaport. And today we have Aviatrix that will be presenting how their solution works with Megaport. And I will intro Abdul. If you'd like to intro yourself, go ahead.
Thank you, Mark, for inviting me to this tech drop-in session today. It's great to be here. So hi, everyone. I'm Abdul Rahim, based out of Melbourne, Australia. I'm part of the global solutions architecture team here at Aviatrix, and I'm primarily covering the APAC region. Prior to Aviatrix, I have been at AWS, VMware Network and Security Business Unit, and at Cisco, with a total of 26 plus years experience in networking and security space. Back to you, Mark.
Thank you. Okay, so today we're going to be covering just a little bit of the Megaport overview, and then I'll hand over to Abdul to run through how Aviatrix works with Megaport and just generally run through the Aviatrix solution. And after that, Abdul's going to do a live demo with Aviatrix and Megaport. So just a little bit of overview of Megaport, again, for those people that maybe sort of new to them. Megaport has a global software-defined network fabric in 25 countries. It's self-service driven through a portal, so you can build data center to data center, data center to cloud, and branch to cloud connectivity within minutes. Next slide, thanks. And to do that, we have a very simple connectivity model. So you can connect to us in over 800 data centers physically using a 110 or 100 gig port. You can go completely virtual, connect multiple clouds together and build a multi-cloud fabric using our Megaport cloud router. And the last main core product we have is Megaport Virtual Edge, which we're going to focus on today. And that is the ability to run virtual network or security network functions on our global compute platform. So we have around 100 locations globally that you can host those functions on our platform, and you can build private connectivity between those functions or to cloud. And to do that private connectivity, we use virtual cross connects. We call them a VXC. They'll join any 2 points on our network, either between a port, MCR, and MVE, or one of those products and a cloud service provider on the right, or a service provider in our marketplace offering services like WebEx and Zoom. Now, with those core set of products, we generally build three main solutions. One of those is hybrid cloud. So if you're in a data center, you connect to Megaport physically, then you build private connectivity to AWS, Azure, Google, Oracle, etc. We're connected in around 280 locations globally to cloud providers. So we have the most coverage in terms of cloud on-ramps globally. And then you're looking at Virtual POP, which is the Megaport Virtual Edge, and that's where you're going to virtualize your network and security functions on our platform. And the last option there on the right is Cross Cloud, which is the Megaport Cloud Router, which is a very easy to deploy, multi-cloud feature set virtual router on our platform that you'll connect multiple clouds together. So just touching a little bit more on Megaport Virtual Edge, because that's what Aviatrix runs on. So we support a number of different network and security vendors, and one of those being Aviatrix. Basically, you spin up a virtual version of their product on our compute, and then you can build private connectivity to cloud, to data center ports, or you can build connectivity over the internet to remote branch sites using SD-WAN technologies. And how that's packaged with Megaport is based on the starting point is virtual CPUs. So you either select 2, 4, 8, or 12. that has associated amount of RAM with each of those. And then you choose as a starting point internet access, which is we provide internet access, so Megaport internet, and you can go anywhere from 20 megabits per second up to 10 gigabits per second, and you can change that at any time. So you can scale from 20 meg up to a gig, back down to 500, all within a minute through our self-service portal. So what I'm going to do now is hand over to Abdul to run through the Aviatrix solution and show you what that looks like in a demo.
Thank you, Mark. A little background on Aviatrix. We were founded in 2014 to provide advanced networking and security, especially designed around cloud and then extending from cloud to other locations such as Megaport. At Aviatrix, we pride ourselves as secure cloud networking experts. We have one cloud networking platform which creates the visibility, the security, and control which any business would need. There are three key areas where customers find immediate value in our solution, which are all around pillared around simplified operations, improved security, and reduced cost. Just to give you a high-level background of the platform, Aviatrix is a programmable distributed system. The Aviatrix control plane is deployed from your primary cloud's marketplace. Then the control plane then deploys and manages these micro gateways. These micro gateways will provide you with additional distributed processing for cloud networking, embedded security, and advanced telemetry. These micro gateways are deployed in your cloud tenancies. These can also be deployed in Megaport, for example, and even on-premises location, as you can see here. The Aviatrix system leverages a cloud operating model with infrastructure as code automation using a single multi-cloud Terraform provider, and it has proven to scale to thousands of VPCs across multiple clouds. The CSPs involved are purely a fabric to build the network that we need. Aviatrix owns the data plane with encryption end-to-end. Moving on, specifically focusing on our partnership with Megaport, Aviatrix is a Megaport virtual edge, as Mark stated earlier. We provide advanced routing and segmentation to achieve optimal diversity and enhance visibility for risk mitigation. So we support secure movement of data using high-performance encryption on the private VXCs provided by Megaport. This helps us to establish secure high-performance data center edge, which is a key requirement to fulfill compliance in financial, healthcare, and some other compliance-based verticals. It also helps businesses to establish secure high-performance data connectivity for their LLM/AI workloads. We are also working together with Megaport to improve the joint customer experience. So there are two popular use cases. The first being secure high-speed hybrid connectivity to the cloud, and then extending this hybrid connectivity across multiple clouds, while we can optionally provide transit functionality for multi-cloud traffic so that the traffic remains within Megaport and is not thrown back to on-premises. With that, I'll stop boring with slides. This is the demo topology that we have built today. This demo topology is tailored towards showcasing hybrid connectivity using Megaport Virtual Edge. Just to highlight that this is not the only use cases that we deliver for customers. We have a wide variety of use cases. For example, uplifting security inside the cloud, whether that's secure egress. Apart from that, we have other use cases that you can use Aviatrix for, which is for traffic inside the cloud, merger and acquisitions, overlapping IP addresses, and the list goes on. So in this specific topology, what we have done here is we have spun 4 apps or VPCs or VNets. There are 2 of them are in AWS and 2 of them are in Azure. The reason why I've showed them in different colors is if needed be, we can achieve network segmentation or VRF-like routing so that blue can only talk to blue and orange can talk to orange. These app VPCs, they connect to the transits, Aviatrix transits, and then the Aviatrix transits connect with the Megaport virtual edge to achieve high speed multi-cloud connectivity. And that connectivity also extends to on-premises as well. So with that, I'll just start with the demo. Mark, keep me honest with the time. So I'll just bring this.
You're looking good.
Okay, excellent. So this is the topology view that we have for what we saw earlier. So here we see that we have AWS here, transits, which is connecting with 2 different spokes. These transits are connecting via Megaport Virtual Edge. So AWS on here and Azure here. We can also see the legend to see what icons represent, right? So this is the first topology view that dynamically gets built. And this topology view can be extended to show even the workloads, for example, in these VPCs or VNets. So if I go to spoke 3, I'll be able to see that there's a VM that represents a spoke, but we can also find, for example, this workloads specifically, and I've clicked on this one of the VMs, so it will give me all the metadata related to that VM, whether that's the public IPs, private IPs, and whatnot. When was it launched, and all of those details. So this is a topology view that we have. Apart from the topology view, I'll walk you through 2 different things. So in today's discussion, the key thing that we're working on is Megaport Virtual Edge. So for Megaport Virtual Edge, if you want to look at the Megaport Virtual Edge in this view, we see that the Megaport Virtual Edge has 3 different neighbors. 2 neighbors are with the AWS and Azure, and the 3rd neighbor is on the LAN side, which was the on-premises router. And if I want to look at the routes that we are advertising or the routes that we are learning, we can see that here just by the click here, right? And if I want to look at the topology, the BGP topology that it shows, then I can go click here and it will give me the big topology of where the MVE sits. And this is the LAN router, and this is where the DX gateway, we are having a BGP peering relationship with the DX gateway. And this is where we are connecting with the Microsoft EE's edge routers here in Microsoft. So this is the BGP topology view that you can see with the AS numbers and the IP addresses that we have assigned for this specific demo. Apart from that, there is a lot of visibility, and I'll just touch on a few of those elements here in today's session. Is we can look at a lot of things. So what I'll do here is I'll just go and start running some. For example, this is a workload that's sitting in AWS, and let's say I'm doing a ping to one of the IP addresses that's in Azure. Then I'll initiate that ping, and if I want to look at that traffic on the virtual edge, then I can go to the virtual edge and look at the active sessions, for example, and I can capture those active sessions, filter those sessions with ICMP, for example. And when I'll run this, it will give me a quick view of what are the different sessions that are happening through this MVE, specifically with ICMP related, right? So I initiated a ping specifically to 4.36, but let's say there is another workload that's sitting in Azure, which is this is the one 4.36. Let me start with another one, which is 3.36. And if I run this ping session and I go back to that gateway and I run this again, it will start giving me the other session that have been created as well. So you have all that deep visibility that typically enterprises would require. But this is just an active sessions. But let me see if I can do a trace packet captures, right? So I can run this packet capture for, let's say, 10 seconds. And I want to filter those again on ICMP because that's what we're doing right now. And I can capture on one of the links that is coming from AWS. And I can run this packet capture for 10 seconds. And we'll see that it will start giving us the live PCAP file that that can be useful for us to triage further. So I'll just download. This is a quick view of the source IP, source port, destination IP, and destination port. But I can even download this PCAP file and open this PCAP file for us to review, right? So let me open this file. And if you look at this file, you can see all the ICMP packets along with their headers, and depending on the size that you choose, you can look at the payloads as well, right? So this is a quick way of doing what network and security engineers have been doing for ages, which is to look at all of the traffic that's going through your environment. Coming back to the demo, there is one other tool that we have, which is very extremely useful to look at and trace the packet path, for example. So this is one of the reports that I ran earlier for you, but what we're doing here, I can start that again, is there's a tool called APAC where I can provide a source and a destination, and I can say that trace all the path and look at all the things between this workloads on using private IPs. And if I run this AppIQ, it will take a few minutes and it will give us a view of what that would look like. So it will print the topology for us. It will show the latencies that the packets are observing in that private data path that you have. And it will also show you all sorts of CSP native constructs, which includes route tables, NACLs, security groups in the VPC and the VNets that this traffic will go through. So that's one thing. It takes a couple of minutes to get there. So that's why I created this earlier. But given the time that we have, I'm just running this again for us to look at. So while this is getting done, I'll just go to this specific MVE, which is our edge, right? We have a lot of BGP and routing controls with the Megaport Virtual Edge. So, for example, we can do all sorts of summarizations, path prepends. We can do route approvals. So this means that we can say, okay, if from the LAN router I'm learning these prefixes, do I want to approve those? Kind of route filtering in play, along with summarizations and all the BGP knobs that you're aware of. Let me see if this has completed. Yes, it has. So in this topology, actually, I shut down some of the gateways. So I built this with primary and HA gateways, but since just to conserve on the infrastructure costs, I've shut down the standby gateways or HA gateways. Those are working in active fashion. We just termed as HA gateways, right? So in this case here, this means that this gateway is down. But if you look at if you trace the packet path from, let's say, from the right to the left, this is the virtual machine sitting in the specific VNet, and it's going through this spoke gateway. Then from there, it will go to this transit gateway. The green path is what we'll follow. And then it will go to the Megaport Virtual Edge, then to an Aviatrix transit, then to a spoke, and in AWS it will land on this test spoke, right? So depending on the traffic, you can find this topology, which is very quick to get. Then you can also find all the latencies around the way as well. So if you click on these, you'll be able to find, okay, what is the latency of these links? And it will show you this data in the tables below, right? So you can find how many packets have gone through between this source and destination. And then you can look at all the different constructs, the CSP native constructs. For example, the NACLs, the route tables. This is the VPC route tables, the security groups, the gateway routing table, which is the Aviatrix spoke gateways and the transit gateway route tables, and the VNet route tables in Azure, for example, right? And any NSGs that this traffic is going through. So you get a good view. And if you are getting a complaint from some app team that blah to blah communication is not working, you can actually capture this information, and then if you need, you can download this in PDF and share it with the application team to get the blame out of the networking team, right? So this is a common thing that we see. This is a very heavily utilized tool by many of our customers. Apart from this, as I mentioned here, this topology that we have now is allowing AWS to Azure connectivity, and that's because we have enabled the transitive routing on the Megaport virtual edge. So coming back to the topology, this Megaport virtual edge is allowing the traffic to transit through. If we needed, we could stop that. So I'll just go ahead and prove it by just starting this continuous ping. But I'll go to the specific gateway and I'll say, you know what, I don't want any sort of transitive routing happening. So we'll go and we'll disable this transitive routing and we'll save that. Once we do that, what happens is the route exchange that's happening between Aviatrix transit gateway, this MVE is sending the routes from AWS to Azure, that will stop happening, and hence the traffic will start dropping. So you see that the ping has dropped. It's not moving anymore. And if I look at it, there's 100% loss now, right? This is just by the virtue of disabling the transit routing. I'll enable that just to see that now the traffic should start working once the routes are exchanged. So these are some of the things that we can do with this platform. Along with this, we can set up a lot of notifications. For example, just setting up an alert to monitor on, let's say, the underlay, if the underlay is available, or the status of the underlay, or the BGP peering status, and we can send those notifications to recipients, which can include email addresses or webhooks. For example, many of our customers use WebEx or Slacks, and they can use this Teams channel to get notified of any of these instances that are happening. How are we looking at time?
Yeah, just a couple of questions, Abdul. How does the Aviatrix encryption compare to IPsec? Because pretty common scenarios, customers will set up and manage IPsec tunnels over Megaport, so they're getting the benefit of private connectivity, high-speed private connectivity through Megaport, but also encrypting the traffic either between clouds or from on-prem to cloud. How does, security is a main part of the Aviatrix product suite. How does that compare to IPsec?
That's a very good question, Mark, and we are typically asked about this specifically. So the IPsec that gets established between Aviatrix appliances, which is an MV in this case, and the transit here that's sitting in AWS, we use a patented technology which we used to before called insane mode, and now the marketing word for this is high performance encryption. What it does is it is able to achieve n into 10 Gbps, and the way we do it is we start using the CPU cores, and we create like n number of IPsec tunnels under the hood, and we pin each of these tunnels to a unique vCPU. So what we typically find with the cloud native constructs is that they are able to scale one IPsec session up to 1.25 Gbps, and then you need to create another one. You can create another one. Some constructs allow ECMP based routing, some constructs don't. But you have to create and manage those tunnels, each and individual tunnel, and make sure that there is uniformity of traffic getting ECMP'd across those links. Whereas with Aviatrix, we create a single attachment between the Aviatrix edge and, for example, the AWS Transit Gateway, and we build n number of tunnels, and that's managed as a single tunnel, and we are able to achieve 10 Gbps throughput, encrypted throughput on that. And anything that goes on Aviatrix, whether that's between Megaport virtual edge and the Aviatrix transit that you see in this diagram, or between the spoke gateways that you see here and AWS transit, everything is encrypted. So in Aviatrix, everything is encrypted by default using the encryption of your choice, which is high performance encryption.
Okay, thanks for that explanation, Abdul. So really, it reduces again the management overhead of those IPsec tunnels.
Yeah, exactly.
Yeah. Okay. The other question was, in terms of deploying the Aviatrix Edge on Megaport. Could you touch on that a little bit, just in terms of what's required, from the Aviatrix console and also the Megaport console in terms of deployment?
Sure.
Yeah.
Sure. Let me touch on that. So let's go back to here. So this is what the Megaport console looks like for this specific deployment that we're doing, which is a test in which we've deployed what we call a Megaport Virtual Edge in Sydney. And while we deployed that, we had one connection to Megaport Internet. And the reason why we need this connection is so that the Megaport Virtual Edge can call home to the control plane components. Then, Megaport Virtual Edge, we added a connection to AWS DX. We added another connection to Azure Express Route. Apart from this virtual edge, in order to simulate the LAN side, I created a LAN router, right? And then I built a private connection between this Megaport Virtual Edge and this LAN router, which is also a Megaport Virtual Edge. While I deploy that, I use the private VXC, and this is what this private VXC represents. So this is the B end, and this is the A end of that connection. So this is how we do it. In terms of creating a new MVE, for example, let me try to deploy one MVE in using Aviatrix. The one thing that you would need, other than mentioning the size and everything, what you would also need is a file. This is called in cloud init file. And the way we generate this cloud init file is we go to a platform and we have this gateway that we have deployed. We can create another gateway in here. We'll select the platform as Megaport Edge, and then we'll start configuring the WAN, LAN, and management interfaces. And based on that, a new cloud init file will be generated, which this cloud init file will be required for us to deploy the Megaport Virtual Edge.
That's great. Thank you, Abdul. I think that is all the questions we have. Have you got anything else you'd like to cover, or are you all done with the demo?
I'm all done with the demo. I have, for this specific demo, I have deployed the Aviatrix side using Terraform, because that saves a lot of my time, even during POVs. For the Megaport Virtual Edge, I was doing ClickOps, but I'll follow up with Mark to set this up using end-to-end Terraform, because Mark shared a Terraform module with me where you can deploy the Megaport Virtual Edge using Terraform as well. So all of these circuits that we have deployed today, for example, this private VXC, the internet connections, all of these pieces can be done using Terraform as well. So that would be great.
Yeah, so as a starting point, customer interfacing with Megaport, they can do everything through the portal, as you see here, or you can use our API, or you can use our Terraform module to deploy the services. So 3 different options there, and the Terraform module works well with Aviatrix, as Aviatrix also has a Terraform module, so you can automate the complete deployment. In terms of, I think we're on just about done. If you'd like to find out more around either Megaport Virtual Edge or Aviatrix, please reach out. If you're a Megaport customer, to your account exec, or if you're Aviatrix customer, please reach out to your Aviatrix account exec. If not, you could reach out to either myself or Abdul directly on LinkedIn, and we'll get you in touch with the right person.
Looks like I had the video off throughout the session. That was not my plan, but
All good. I think we got all the right information.
okay.
So thanks for your time, Abdul. Appreciate you presenting Aviatrix. Really great technology and works well with Megaport. Thanks for your time.
Thank you.
Okay. Thanks everyone for joining and have a good rest of your day. Thank you. Bye.
Cool. Thank you, gentlemen. I'll let that just finish live streaming and I'll cut it and then I'll edit this part out and this on the top as well.